Hello everyone, welcome back to the channel. Today's video we're going to be going over Maddox. We had a great tour at their site, showing you guys their transformers, showing you guys the internals of those transformers, how they convert 12,000 volts down to 480, going over all the details of a transformer. Very nice video for you guys today. So if you guys are interested, you know what to do, hit like on the video, subscribe to the channel, go to cryptollc.org. If you're looking to build an ASIC farm, you're looking to do some hosting, buy or sell miners, we'll have all of that at cryptollc.org. Today's video, I'm in the park, but I will transition over to the tour video here shortly. But before we do that, I wanted to go over how the whole Maddox situation worked out. It's really interesting how it happened. So there's a YouTuber watching our videos on YouTube. Shout out to Chad. And he has been going to a church down in Battleground, which turns out that Maddox, also a lot of their members go to that same church. And Maddox, it's a big manufacturer of transformers, has their one of their manufacturing locations in that same city. So what happened was, when he was driving by our down next to our farm, he looked at our farm and said, "Hey, that kind of looks familiar. Looks like the farm I'm watching on YouTube." So he reached out to us, and turns out it was correct. That is our farm location. And then at that point, he told us about Maddox, which we didn't know. We didn't know it's like that close. It's literally 5 minutes away from our farm or our data center there. Very interesting. And so we met in Nashville, the Bitcoin conference 2024 in Nashville. We met both Chad and Maddox. Maddox had a booth there, selling their transformers. So very interesting. So we met the Maddox team, and after that we said, you know what, let's, if we can get a tour of the place and talk with your guys' sales and everything, and they agreed to that. And that's how we got this tour video, which will start here shortly. So very interesting setup there. How everything turned out is great. Looks like God set that up for us. It's nice providence there. So hope you guys liked the video. Very detailed. And we met also Mac. He's the vice president of sales. So he's going to be the voice you're going to be hearing as we go through the whole manufacturing plant there. So hope you guys like this one.
So this is the third shop that we've built, and this one opened in 2018 to serve our customers here on the West Coast. So we started in South Carolina. We've got about twice the shop capacity as we have here in South Carolina. And what we do at these sites is we rebuild transformers. So we get old transformers from utilities, contractors, and end users. Basically take them down to the studs, replace any defective and broken gauges or components, gasket everything, repaint it, and power test it. So we know it works as well as looks like new once we're done with it.
Well, when the transformer goes down, what usually breaks on them? Like typical problem.
Yeah, so total winding failure is pretty rare. Usually it's the ancillary components kind of inside the transformer, so it's switches, fusing. A lot of the parts and pieces that are inside the transformer can fail before the actual transformer itself fails. So we'll take a look inside one that can kind of point some of those things out to you.
All right.
But usually by the time it's arrived here, it is a fixable transformer, and the place where we start is right here through this bay. The trucks get offloaded right into our receiving area, and then we send the transformers through a battery of tests that tells us if it's fixable and what might need to be fixed on it before it gets reconditioned.
All right.
So this is an example. This right here is actually a new transformer. So these are manufactured at our partner factory in Tennessee. So about 75% of the transformers that we sell are new off the line, and then another 25% are reconditioned. So we keep a ton of stuff new in stock as well as reconditioned, ready to ship.
Okay.
That's really our business model.
What range of transformers do you guys sell? Like I see a 300 kVA here, 300. That one looks pretty large over there. You guys go up to like 5?
Yep, we go up to 5. We can do up to 25 MVA. It's about the max size we do in 115 kV. But the majority of the transformers we sell are kind of in this range. I think our average kVA is like 2,000.
Yeah. So you sell up to 25?
25 MVA.
But that's like for a substation, right?
For a substation, yeah.
Okay, but what about for like distribution line?
For a distribution pad mount, typically the largest you'll see is a 5 MVA.
Yeah.
Most common going into Bitcoin mines would be a 2,500 or a 3,000 kVA.
Yep. Okay, so up to 5. Interesting.
Yep.
Is there like a big price difference between those? Like let's say you got the 300 here. Like 300, obviously there will be a price difference, but between like a 2 megawatt and a 5 megawatt, is it like a big price difference between those?
Yeah, it's about double. It's about double the size, so about double the cost.
Okay. That's a beefy one. What is that? That looks like a 5.
That's probably a 2,500 or a 3,000.
That's like huge.
So this is a 3,000 kVA.
Dang, that's huge for 3,000. Because we saw some other 3,000s at one of the power companies in North Dakota when we were just looking around down there, and theirs were smaller size.
Okay.
Like they were maybe, I guess, not. I don't know. This one looks like it's gonna cool really good.
It actually has a 15 kV secondary.
Oh, maybe that's why.
Yeah. Yeah, so the spacing inside would need to be a lot larger for clearance.
15 kV secondary. Can you remind me what that is?
So the incoming voltage on this transformer is 13.8 and the outgoing is 13.2. So it's actually a very unique transformer.
Oh,
Typically,
okay.
you'd be stepping down from 13.2 to 415 in your case, or 480.
Yeah. Why are they stepping down to 13.2? That's like
That's a great question.
That's a 600 volt drop.
Yeah, that's a great question.
Why? That's
There's so many different applications.
that's
so,
interesting. They needed 600 volts down.
Yeah, exactly. It could be that they have some 13.8 equipment.
Yeah.
You know, they bought some big motors or maybe a large generator or something in the system. It's 13.2 or 13.8, and they couldn't get there with their adjustment taps.
So they're like manufacturing out there where the units that they use for like a mill or something, they actually run at 13,000 volts. Does that actually happen?
That's a good question. I mean, 15 kV, that whole range, the 13.2, 13.8 is a distribution voltage. I'm just theorizing though. Yeah, there could be some very large motors that run at 15 kV.
Yeah, that seems.
I know more about transformers than I do.
Yeah, like 415. Like if something runs at 415, I guess that's probably. I mean, I never seen one before, but I would assume that like in a mill or something, like those gigantic $1 million generators or whatever they are.
Yeah.
Manufacturing things, they probably run at 415, but like 13,000? Who runs at 13,000?
Yeah, I don't know. That's a good question.
Huh.
Yeah. We
Interesting.
see all kinds of transformers come through here.
Yeah, so you guys build customized stuff, right? Like,
absolutely. Yeah.
So if someone comes in, like this guy over here, and he says, I want 13.2, like, yeah, we can build you a special custom transformer at 13.2.
Yep, absolutely.
Oh, okay.
Yeah. Yes, we can take a look more at the kind of process as we go along through the shop.
Yeah.
So the transformers that are going to be reconditioned are offloaded right here into the receiving area. Like I said, we do tests. So initial tests are MEG, TTR, resistance, and dissolved gas analysis. And PGAs are basically like a blood test for a transformer. So if there's any kind of arcing or overheating inside the transformer during while it's being used, that'll actually alter the chemical makeup of that fluid. And so it'll tell us kind of what needs to be fixed. So by the time we sell the transformer, we already know kind of what will need to be done to that transformer to get it back to new, basically.
Okay. What is so when you're saying ancillary brake, like is that inside the transformer, or is it any of these knobs I see over here? Yeah,
it would be. We'll take a look at a core and coil down here, and you can kind of see all the components that are wired up to it. So our paint booth to the left. And our test set. So we run it through the standard IEEE C57 test results that a new transformer goes through.
Yeah, I see you guys offer a 3-year warranty for transformers. Is that still the case?
Yep, for both new and reconditioned.
Okay. And then what if a client comes in and he says, I want, you know, a longer warranty? Is it like you sell like special service packages for that?
Yeah, we've done up to 10 years, I believe.
Okay.
Yeah, absolutely. Yeah, so this is the transformer that's in the middle of reconditioning, and you can take a look in here. So there at the bottom, you've got your core and coil. Mm-hmm. That's the active parts of the transformer. This one has current limiting fuses.
Okay.
So those are partial range backup current limiting fuses, and then your bayonet fuses. The bayonets are to clear just kind of low level faults or overheating, or basically if the transformer is being run too hard, those will blow. So that's kind of your average kind of overcurrent protection, and then the backup current limiting fuses are to catch any high level faults that the bayonets.
These ones over here?
Clear. Yeah.
So these catch high level faults. These ones, you said, I mean the voltages are from the power lines. These are coming through these.
Yeah.
Okay, right. So that's 3 phases coming in.
Yeah.
And then these are for, what are they again?
Those are bayonet fuses, and they're just for low level faults.
Okay.
Low level faults or overheating.
Okay.
Or overloading. So those are kind of your standard duty. The current limiting fuses are really for massive failures. So by the time the current limiting fuses fail, the transformer itself is actually failing. The CLFs are actually there to protect the system from the failing transformer.
Okay.
Yeah. So the bayonets are made to be changed out. So you can see here in the front. They're called bayonet fuses because they pull out kind of like a bayonet.
This thing's full of oil.
It is.
Is it like to the tippy top? Oh, I see top right here. Is that where it goes to?
Yeah.
Oil level? Okay.
Exactly.
So when you pull that out, is this thing under vacuum?
It's under pressure, actually. Yeah, it's got positive pressure on it. And the airspace inside is nitrogen, because nitrogen doesn't hold moisture, so it's better than oxygen.
Okay. So it shouldn't rust.
Yeah, it shouldn't rust, and that positive pressure, you always want to have positive pressure on it to prevent moisture ingress.
And then your tap switch, is this the tap right here?
That would be the tap changer, yep.
Okay, so that's the
so
tap.
you can see that operating. It's just let's see if I can get it to operate. Yeah, so that adjusts your incoming voltage. This is a no-load tap changer, so you can't have the transformer energized while you change it. But if you're right next to the power plant and the voltage is really hot, you can adjust it up. If you're downstream of the power plant, the voltage is starting to sag a little bit, you can adjust the incoming voltage there to maintain the steady secondary voltage.
Yeah. And then your, what are these called? Plates or?
Secondary lugs, yeah.
Yeah. So after that conversion, so you got the voltages coming in here. They travel.
Yeah.
Interesting, they just got a tiny little, well, actually no, it's pretty thick over here. But still, it's got like what, 13,000 volts on it? Or 12,000 volts for Clark, I think?
Yeah.
So traveling through this, and then, oh, you have your extra connections here for your other transformer if you want to connect one.
Exactly,
These are for?
Yeah, it's loop feed, so you can daisy chain them.
Yeah, I can daisy chain them.
Yeah, the higher the voltage, the lower the amperage. And the lower the amperage, the smaller your wire has to be.
Yeah.
Yeah, the wires are very small. And if you look in one of those bayonet fuses, I mean, all of that current and voltage is going through a very thin element.
So I'm looking at this right here. So you see this wire, this orange one connected here. So this is high voltage, like 13,000 volts, whatever it is. That's what it's going to this fuse. And then from that fuse is going over here.
Yep.
And then from there it's actually going down to the coils.
That's right.
So if this is how much kVA? Like
like a 300, I think.
So 300,000 watts can travel on this tiny little wire.
Yep, 300,000 volts. Or well, let's see. No, this is, let's get, so 300 kVA.
Yeah.
Yeah, so 12,000 volts.
12,000 volts. That's crazy. That's a lot of savings right there. I mean, I imagine putting 300,000 volts at 240.
At 240,
Yeah, you need like a wire like this.
Yep. Right.
Yeah, so they're really thin. So for like, I'm just trying to visualize what our 2.2 megawatt looks like, but probably like, what is it, 6 aught or something like that. Probably traveling. Interesting. So very, very thin wires, and then they go down to the coils.
Yep.
And then from the coils, they come back up here to the plates.
And this is the secondary. So this is at 480 volts. So that's that same amount of wattage, but step down that lower voltage.
Yeah. Well, that's nice to see this, and you know, it's one of a kind here. To see it in person, the transformer taken apart. Interesting. So if the oil runs out, well, it doesn't. It's not going to run out. But if the oil, does the oil ever like decrease in quantity?
No, it really doesn't. It's not like fluid in a car. The oil inside of a transformer is really there for heat insulation as well as electrical insulation. So there's no mechanical function really inside the transformer. I mean, there's the tap changer, which is a mechanical component, but in its operation day to day, there's not mechanical wear like inside of a car engine. So the oil doesn't go bad per se, unless there's overheating or some kind of issue inside the transformer.
Yeah, but do you ever have to like top up the pressure, or maybe? I guess you don't top up the oil, but what about the pressure? Does it ever go down?
Yeah, the nitrogen. It does, depending on the temperature outside, right? So we'll ship transformers sometimes at positive pressure, and they end up on site, super cold at the site, like in South Dakota. Yep. And the pressure will go down. It may even pull a vacuum, and that's really not anything to be concerned about. Really, what you're concerned is that the tank is holding pressure. So it could be a vacuum or it could be, a couple pounds. Ideally, you want to run your transformer at 2 pounds of positive pressure, but it'll sometimes dip into a vacuum. The only thing you want to be concerned about is if it has zero, if the pressure gauge reads zero.
Yeah.
That means the tank actually isn't holding anything. There may be a pinhole leak somewhere.
Right.
So it's airtight.
Yeah.
Whether it's pressurized or a bit negative, less than important, but that it's airtight.
Exactly.
Or that it maintains its airtightness.
Yeah.
Yeah.
Exactly.
So like for cold states, you're saying the pressure will go down. Okay, but does it pick back up if it gets warmer?
Absolutely, yeah. And typically, when you get those calls, it's just that they haven't energized the transformer yet. The transformer, it generates some amount of heat.
Oh, okay.
Losses in the form of heat.
So if it's just sitting in the cold.
Just sitting in the cold, it'll probably be under a vacuum.
But if you turn it on, so if it's in the cold, let's be sitting there for like a couple days, so it's really, really cold, it's freezing, it's like minus 20 outside, is it still okay to turn them on, those transformers? Like turn them on and just put them to full blast, 2 hours later, let's say. So you have your container of miners ready to go, but you have a really cold transformer sitting there. Is that safe to turn it on?
There's a startup procedure that I can send you. We have an article on our website that talks a little bit about that. And most people, you want to kind of load it up gradually. You don't want to just switch it on at full load. So there is a cold start procedure.
Okay.
But at this size, it's pretty basic. When you're talking about a massive substation transformer, that's a larger concern. But with these small units, it's pretty basic.
Yeah, because that'd be kind of different for like a substation. Because if you have a substation out there, and let's say your farm went down for whatever reason, you lost internet connection, and it's minus 20 outside. Yeah. I mean, the substation transformer will become cool really fast.
Right.
But then if you come back online because your internet came back on, you got 20 megs going online, is that bad for the substation transformer? Or is the substation... Could be.
It could be, yeah. You typically want to bring your load on gradually.
Yeah.
Yeah, so slamming it off and slamming it back on, multiple times a day would wreak hagok on transformers, and that can cause a failure.
Yeah.
You guys have the capability of firmwaring your machines to turn on, and you should be able to code that, right? If you have a fault, you should be able to, you have like a firmware that sets.
Yeah, we can do that. Yeah, we could. It's just like for that power, the power company also has curtailments. So they could come in at like 3 a.m. So let's say their transformer lines are overloaded, or for whatever reason, they give us a event. They tell us to turn off 20 megs or 50 megs or 100 megawatts, like now.
Yeah.
So and then the event will come back like, okay, you're good to go an hour later. But they're not going to tell us you're good to go incremental. They're just like, you're good to go.
Sure. Yeah.
So like, I guess I have to talk with them to not fry their substation
right.
transformers if they're in the know of that, what to do there.
Yeah.
So, but that's good to know. Be asking them. Now, by the way, so you guys do make substation transformers, right? Like 50 megs, 100 meg. Well, I don't know. Does 100 megs exist?
They make 100 MVA. Yep. I've seen up to 500 MVA. Our max is about 25 MVA, so 25,000 kVA.
Okay.
We'll take a look at some bigger ones outside too.
Expensive, right?
Yeah.
Those are like $1 million
like
plus.
$1 million, yeah, or more. Yeah.
Okay.
So this big blue oven is our dry out oven. So anytime we take a core and coil outside of a transformer, you have to bake it out to get all that moisture out before you retank it. Electricity and moisture don't mix.
Okay.
So this oven, I think it runs like below 300 degrees, so it's not super hot, but it just gets all that moisture out of the windings, because just having a transformer sitting out in the open like this,
Yeah. What?
the insulation material will soak up some moisture.
So the coil, what is that compound? Is that copper?
It's either copper or aluminum. Aluminum is more popular just because it does basically the same thing as copper. It's just a lot cheaper.
Yeah. Do you have to still double the amount of it for aluminum, or is it like
it's not
what's
quite double, but it is. Yeah, you use more aluminum because at a molecular level, copper is a better conductor than aluminum, of course.
Yeah.
So
yeah.
you use more. So you've seen, the difference between a copper wire and an aluminum wire is pretty significant.
Yeah. Well, and then aluminum weighs less, too, right? I think than copper.
It does.
Yeah.
Yeah, it does, but because you have to use more of it, typically an aluminum wire transformer will weigh more than a copper wire.
Oh, okay. Yeah. Interesting. So these get moisture, and then what are the moisture? How do they get moisture in there? Is that like just a really old transformer?
It could be. In this case, what we mainly use our bake out oven for is just if we have to take the core and coil out to work on the transformer, before we submerge it back in oil, we need to bake it out to get it nice and dry. And if you don't, your insulation resistance will be really low. Right? So, yeah, a transformer can get moisture in the oil over time if there's not a airtight tank. Right, but in this case, I mean, usually it's just because we've taken it out, it's in the air, and there's enough humidity in the air that it'll actually negatively affect the insulation resistance.
Do any of these transformers have, because I'm looking at it, most of it looks mechanical. Do any of them have like electronics, like microchips in them, or?
No, there's some monitoring that can go on the outside, and it just gets data just from analog gauges, heats and pressure.
Yeah.
And there's all kinds of complicated kind of SCADA systems that you can set them up to send you a text if it gets over a certain temperature. So, but inside the transformer itself, there's really
Yeah, I don't see any. Interesting.
yeah.
And do you guys provide like if we wanted to get a transformer with a meter, right? Like on the I guess it's put on the outside of it. Is that something you guys provide for your transformers?
Yep.
Okay. Yeah, so for some of our clients, it might be cheaper just to put a meter right on the transformer.
Yeah.
Then put it in the container,
Sure. Yeah.
and then we just measure it at the transformer level.
Yep.
Okay, nice. You got your sea of transformers. Do you guys have a pretty good stock of them? Like if someone wanted to get 10 transformers at 2.5 megs or 3 megs, is there a lead time? Because I know a couple of years ago there was a giant lead time for that. And
Yeah, we've got a lot of 415 Bitcoin units in stock. We've got about 3,000 liquid fill transformers in stock across all of our locations. Not all of them are that 415, 240 voltage that you want for your mine. Are you running that 415 or 480?
415.
Yeah, so we've got a lot of that in stock. But it depends on your primary voltage, so we don't have every single kVA and voltage combination. So there may be a short lead time. Right now we're quoting custom built pad mounts about between 25 and 40 weeks, depending on the size.
Okay. 25 weeks? So
Yep.
what is that in months? 5 by 4? What is that, like 8 months
4,
or something?
6 months, something like that. Yeah.
Okay. And all of these transformers are just, are they sold or are they just in stock and ready to?
A lot of these are sold. So the ones to the right here with the bushings on the side, those are sold to a data center, and we have a storage agreement with them. So we do a lot of inventory planning solutions for large data center clients. So we'll keep a few hundred in stock for a large data center.
Data center like AI or data center like crypto?
Those are traditional data centers, so
Okay.
I don't think they're cloud computing. But
And then-
we would definitely be willing to do the same for a Bitcoin mine as well.
Yeah.
It's all just transformers to us.
And then switch gears, you guys provide those. You have any out here somewhere?
We do, yeah. We'll go across to the warehouse and take a look at the dry type
All right.
storage area. We've got some switchgear over there. We keep pad-mounted switchgear in stock as well as metal enclosed. So to the left, we've got a ton of brand new units that are either part of an inventory planning program with like a data center client or somebody like that, or those are new stock ready to ship to customers. And then on the right, we've got a bunch of transformers that are reconditionable and ready to sell, and those are in their inventory system, so the sales guys can look it up, see what needs to be done to the transformer, see what kind of lead time it comes with. And once we get an order for those, we'll recondition those and ship them out.
For refurbished transformers, are those, you guys sell refurbished ones? Mm-hmm. Okay, and do you know what the average price is, like a decrease in price for versus new?
It's between half price and 20% below new.
Okay. And then they come with what, the same 3-year warranty?
Absolutely.
Okay.
Yeah.
It's a good deal. Oh, you got a praying mantis. Yeah, just bit them.
So, let's start over. This is component storage overflow warehousing as well as dry types.
Mm-hmm.
So we keep a ton of dry types in stock, and these are typically stepping down from a lower voltage like 480 down to 208 or 415. So we sell a ton of transformers that are going from 480 to 415, sometimes 208 stepping up to 415.
Yeah.
Crypto mines.
Yeah.
We keep thousands and thousands of these dry types in stock and ship truckloads out every single day. So these are less expensive than the oil filled, but our volume's a lot higher in these.
Yeah, you sell a lot more of these than those other ones?
By unit count, yeah. Yeah, it's, a unit, average KVA here is maybe 150 or so. Mm-hmm. Whereas our average KVA for oil filled is, around 2,000, so.
Yeah, it still has the same warranty? Like 3 years?
These come with a 5-year warranty, these dry types. Yeah, and if we can get back here, we're a little cramped on space, but you can see metal enclosed switches in stock ready to ship. So those are basically your big on-off switches. Mm-hmm. 15 and 5 kV in stock.
Those tall towers right there.
Mm-hmm. Yeah, exactly.
So switches, are you talking about are those the gear? Or is that like the switch gear, like multiple transformers on it type of switch gear? Or
Usually there's one big transformer on them. So here's some right here. Take a closer look. They're basically just a massive on-off switch.
Yeah. So instead of getting a disconnect, you would have one of those.
Yeah, and we just sell medium voltage switch gear. So this is 15 kV. So this goes in front of a transformer.
Yeah.
So your cables come in the bottom, out the top, and these empty spaces are where your fuses go. So these are fused disconnect switches. Let's see if I can actually operate it. I think it's locked. But.
So what would be the benefit of having this? Let's say if you only have one transformer, what would be the benefit of this versus just having a disconnect switch?
Inside the transformer?
Well, no, like outside. Like you have a pole, disconnect switch, then transformer. Like at our site, we have a disconnect switch set up.
Is it up on a pole?
Yeah. You can stand like yourself and just pull the disconnect, but it disconnects the pole.
Okay, gotcha. Yeah, so that's effectively what this is. Yeah, so there's different ways to do it. There's GoAB, gang operated air breakers. There's these. Sometimes you'll just see that there's fuse cutouts, and they just pop the fuse, the cutouts out to cut power.
This is for the inside, right? Inside of a building?
Inside or outside.
Okay. Because then I guess for inside, this is more understandable. You're not disconnecting like the pole itself.
Mm-hmm. Right. Yeah, these we stock them as NEMA 3R, so they're outdoor rated. But half and half, they go indoors or outdoors. Mm-hmm. Yeah. So this is not the disconnect between 480 volt supply to 415 or whatever. This is straight from the utility at 15 kV.
Okay.
Yeah.
Nice. Do you have any switchgear that's made for multiple transformers going in, like say 3 transformers going in?
We do sell some of the lineups, so we can put these together and make a lineup. More often than not, that kind of switching is handled with loop feed transformers that have sectionalizing switches in them.
Yeah.
right? So if you daisy chain 2 transformers together, oftentimes there'll be a selector switch that you can turn off the transformer downstream, or just turn off that one and keep the one downstream.
Can you put like a switch in each transformer and then just kill
Yeah.
that one transformer, but then not kill anything down the line?
Right.
Okay,
Exactly.
got it. What are these over there? Those just transformers?
These are medium voltage dry type transformers. Yeah.
Are they kind of similar? What's the difference between these and the outside ones? Dry type, you meaning like internal, inside buildings?
Yeah, they could be indoors or outdoors. Most commonly, they're indoors. So you would use a medium voltage dry type transformer any place where you can't have a giant tank full of oil. So if it's going indoors, that could be a fire safety hazard. If it started leaking and then caught fire, super unlikely, but oil will burn at a certain temperature, right? So that's why if you have to bring medium voltage indoors, oftentimes it's going to be into a dry type transformer.
Okay, it's a lot of coil.
Yeah.
They're really, really round.
Yeah.
Is there a reason for so much coil? Is it like a smaller step down or?
So this is a circular disc wound transformer, and most of the time what you see in a liquid filled unit is rectangular layer wound. So there's kind of different reasons to do the different kinds of design, but most medium voltage dry types have circular disc wound windings for the high voltage, and so that requires a lot more space.
Oh, I see why it's like that. It's because you're cooling them off.
Right.
And you need to separate the coils.
Yeah, exactly. Yeah. Yeah, so one benefit to oil filled is it just takes up a lot less space,
Yeah.
because
Okay,
that
I
oil
get
is going
it,
to be going to pull the heat away from the coils a lot faster than the air will.
Right.
So
But then for that, so the oil is circulating then inside of inside the transformer, because
Yeah.
if it's just heating up in one spot, then it's kind of just heated up that oil at that location. But if it's not moving, then
Right.
how is it dissipating the heat? So is it traveling through the fins? Is there some kind of
Right.
pump inside?
there's some large substation transformers that have pumps inside of them, but most of them just operate with natural convection. So as the oil rises, it goes to the top, and then there's inlets that let the oil go into the fins, and then as it gets into the fins, the air will cool it off, and it'll
goes
drop to
down.
the bottom. Yeah, so it just creates kind of a circular motion.
Nice.
Yeah.
Okay, that's
You don't
a
have that with
mechanical
dry type
solution.
Exactly, yeah. Yeah, it's really elegant design. So with dry types, you don't have that as much, so dry types will have fans on them more often than a liquid filled will.
Great. And then this one is just a different type of dry one.
This one looks like it's past its prime.
Looks like he's
That's a really
Old
old
one.
transformer. Yeah, transformers are designed to last, 30 years plus, and they can last a lot longer than that. I've seen them pulled out from sites like in Buffalo that they've been running since the 30s or 40s.
yeah.
So if properly maintained, they last a long time.
Well, some geniuses invented all this, huh?
Right, yeah.
Is there an insulation component in the oil too, like for arcing inside? Mm-hmm. Is that a thing? I mean,
Yeah. It's the electrical insulator. So, air ionizes at some point, which is when that's what lightning is the air ionizes and then the electrons jump to ground.
sort of drives bigger for the same amount of voltage for that too, like to separate the parts out more than
Exactly.
you have to.
Exactly. Yeah, that's exactly true. It's easier for a dry type to jump to ground. So, whereas in an oil filled unit, you could have the core and coil up against the tank like this. You couldn't with a dry type because you don't have that fluid to act as an electrical insulator.
Okay.
It wants the ground.
Exactly.
It wants it.
Yeah.
I wonder how much easier building electrical circuits would be if you didn't need a ground.
Yeah. Probably a lot easier. If only physics.
Come on, Elon Musk, figure it out.
Come on.
Yeah. Heard all about that, like fusion or what other technologies they're looking into.
Mm-hmm.
Maybe one day they'll have something new. Like this stuff came out when it was like the light bulb invented.
Yeah, this was Nikola Tesla, Westinghouse, Edison. Yeah.
Yeah, not that long ago.
Yeah, no, not really.
Yeah.
Not really that long.
I always
ago.
feel sorry for all those people that live like in 300 years ago with no AC.
Yeah.
Like, oh man.
Oh, yeah.
You
Not many
like-
people live in Florida then.
No.
Yeah. Saw Miami. I was out in Miami before, and you drive past some of the homes. They have like tours, and the homes have been there for like more than 100 years. I'm like, you didn't have AC. What were you doing?
Right.
Suffering.
you were suffering in Miami, or all those homes. What is it, the Victorian homes? Oh man, back in like South Carolina, North Carolina. Oh, yeah. Poor people.
I was reading something though, kind of health guru guy talking about how your body's meant to be hot and cold. And there's elements about our life today where you spend your whole day at 70 degrees pretty much, night and all day. That there's something about, I can't remember all the details, but something that your body does by way of like recharging, for lack of better words, getting really cold and getting really hot. It's related to the whole grounding thing. They say you're supposed to be barefoot at some point.
Right,
on the
right,
earth.
yep.
It was like
Yeah.
connected to that somehow. And
Oh yeah.
it sounded kind of legit, but it's also kind of like, oh, I don't know.
Is this too, am I too crunchy right now?
Right,
I like it about 70.
yeah, I know. I do too.
Yeah, but I do sauna. I do sauna.
Do you?
Yeah, I have a cold plunge. I don't really use it that often.
It's the same kind of
Yeah.
medical thinking as the cold plunge and sauna.
Right.
It's just like au natural.
My bed is grounded though.
Right?
Yeah,
Is
my
it?
wife's like, yeah, she bought a sheet that goes over and you put it on under everything. And
Just get a copper wire, stick it in the ground, just hold it with your hand and go to sleep.
see what happens. Start growing a plant like that.
Are these plates, are they steel?
Those would be aluminum, either aluminum or zinc coated copper. And those are low voltage bushings.
So when we pulled wire on them, they felt pretty sturdy. I was like,
Yeah.
what are these things?
Yeah.
Felt different than aluminum. But. So in terms of conductivity, so it'd be obviously copper, aluminum, but what's after aluminum? Does anyone use anything after that? Or is aluminum kind of the standard? Is there really no price, or like there's no economic sense to use a different type of metal?
There's really no economic sense in using any other kind of conductor. So, materials like gold and silver are highly conductive, but obviously there's no economic case for that.
Yeah, no one's gonna use gold or silver.
Yeah.
And then like steel or what other metals are there? Other than steel, aluminum, steel.
Yeah, there's none that are really
Copper.
conductive enough to really be used in transformers. It's really just copper and aluminum.
Yeah. All right. Guess we good?
Yeah, absolutely. Anything
All
else
right.
you want to see?